Picture this: no lights, no stove, no candle, no spark, just you alone in a darkness so total it swallows your own hand in front of your face. Now take away every escape from that darkness. Forever. That's not a power outage. That's the world without fire. Bad. And if that world had actually happened, you would not be watching this. Not because history would look a little different, because the creature capable of making this video, and the creature capable of watching it, might never have become what we are. Your skull, your digestion, the shape of your jaw, the places humans learned to live, the technologies that eventually carried us into space. All of them may trace part of their history back to one relationship, our relationship with fire. Erase that relationship, and you probably don't get a slightly slower version of humanity. You may get something completely different, because fire wasn't just another tool we picked up along the way. It may have changed the direction of human evolution itself. The cave sits in the Kuruman Hills of South Africa, a low mouth in red rock that has swallowed daylight for more than 1,000,000 years. Deep inside its ancient layers, archaeologists found traces of ash and burned material dating to roughly 1,000,000 years ago. What exactly those early hominins were doing with that fire is still debated, but here is the possibility that follows from it. Humans were badly equipped for the dark. No claws, no natural armor, no powerful night vision. After sunset, many predators had the advantage. Then, somewhere in that darkness, something changed. A flame appeared that didn't come from the sky. One you could feed, one you could protect, one that stayed alive because you refused to let it die. For the first time, a defenseless primate held a small piece of the night in its own hands. But fire's greatest transformation may have started somewhere even more basic. Inside the body, a chimpanzee can spend hours every day chewing tough, fibrous food. Its teeth, jaws, and digestive system are built for a world where food arrives raw and difficult to process. Humans are different. Our jaws and teeth are relatively reduced compared with those of many earlier hominins and other great apes. And our bodies must somehow support one of the most expensive organs in the animal kingdom. The human brain makes up only a small percentage of body weight, yet it consumes a remarkable share of the body's resting energy. So where did that energy come from? One possible answer is cooking. Primatologist Richard Wrangham has argued that humans didn't simply discover cooking after becoming human. Cooking may have helped us become human. Heat softens meat. It breaks down plant structures. It can kill pathogens, and it can make some nutrients and calories easier to access. In other words, cooking does part of digestion before food ever reaches your stomach. Less chewing, more accessible energy, potentially more fuel for an expensive brain. The exact evolutionary relationship is still debated. Scientists don't agree that fire alone caused the human brain to expand, but reliable access to cooked food may have changed the biological limits our ancestors were living under. Take that advantage away, and the path changes. More time spent processing raw food, more energy demanded by digestion, different pressures on teeth and jaws, perhaps less energy left over for anything else costly to run. But food was only the beginning. Fire also changed time itself. At Gesher Beno Yaakov in northern Israel, researchers found evidence associated with repeated fire use dating back roughly 790,000 years. Burn materials appeared repeatedly in particular areas, suggesting fire was becoming part of the landscape of human life. Before artificial light, night was a wall. For most animals, darkness changes the rules. Movement becomes more dangerous. Vision becomes less useful. Predators with sharper senses take the advantage back. A tended fire pushed against that wall, and something unexpected slipped through the gap. Not just extra hours, company. Anthropologist Polly Wiesner found something fascinating while studying the Juhansi people of the Kalahari. During the day, conversation often focused heavily on practical concerns, but around the evening fire, storytelling became far more prominent. Myths, experiences, shared knowledge that doesn't prove ancient humans behaved exactly the same way, but it suggests something powerful. Fire may have created one of the earliest protected spaces for human culture, because knowledge doesn't survive through genes alone. Someone has to remember where the water is. Someone has to remember which plants are dangerous. Someone has to remember how to hunt. And someone has to tell the story. A fire may have become the place where those stories survived. Take fire away, and you don't just lose cooked food, you may lose the circle itself. Night becomes dangerous again. The nighttime hours for teaching, storytelling, and shared memory disappear with the light. Culture might still emerge, but perhaps much more slowly, under very different conditions. Then there was the map. Most people assume fire's greatest gift was warmth, and warmth mattered. But the deeper question is whether our ancestors could have reached colder places without it at all. Early humans eventually moved far beyond the warm environments where their ancestors evolved, into seasonal climates, into unfamiliar landscapes, into places where a relatively hairless primate faced freezing nights. Fire wasn't the only adaptation that mattered. Clothing, shelter, and other technologies played their part too. But fire changed what was possible. Remove it and the map may shrink. Some migrations become harder. Some environments become impossible. The boundaries of human survival move closer to the warm regions where our lineage began, but the history of fire is messy. Scientists still debate exactly when early humans moved from occasionally using naturally occurring fires to truly mastering the ability to create and maintain flames. Ash disappears. Sediment moves. Ancient fires leave traces that are easily destroyed. Some of the earliest evidence is controversial. Other sites provide stronger evidence for repeated use. By roughly 400,000 years ago, evidence for regular fire use becomes much more common. Before that, the story becomes harder to reconstruct. And maybe that uncertainty tells us something important. Fire mastery was probably not one single moment of genius. It was a skill, something learned, something lost, something rediscovered, something passed from one generation to the next. Imagine the responsibility: rain, wind, migration, a river crossing. The person who knows how to protect the embers, dying before teaching anyone else. For a group that depended on fire, losing it could be catastrophic. So perhaps the deepest history of fire isn't about the first spark. It's about continuity, someone keeping it alive, night after night, generation after generation, for hundreds of thousands of years. And that small act may have changed everything that followed. Because a kept flame doesn't stay a campfire forever. Give people a fire they can trust, and eventually someone stops just cooking over it and starts asking what else it can change. Clay, baked hard enough, becomes pottery. Or, heated and transformed, gives up metal. Metal, shaped and sharpened, becomes tools that outlast the hands that made them. Every one of those leaps needed the same thing our ancestors first learned to protect in the dark: heat, kept alive on purpose, long enough to change something forever. The path from a campfire to a rocket isn't a straight line, but it isn't completely disconnected either. Again and again, human civilization learned to control energy, and the earliest and most important form of that control was fire. Take it away permanently, and there is no obvious substitute, no reliable way to transform food through heat, no simple source of warmth on demand, no portable artificial light, no easy path toward pottery and metallurgy. A fireless species might still be intelligent. It might still use tools, it might still cooperate, but its future could be radically different. Perhaps civilization still emerges. Perhaps something recognizably human still survives. Or perhaps fire was so important that our entire evolutionary path bends in another direction. We cannot know for certain, but that uncertainty is what makes the question unsettling. Return then to that cave in South Africa, to the ash, to the burned fragments hidden beneath layers of earth. It's easy to see something that's small and think it is only dust, a footnote in a story written by Bones and Stones. But if fire helped reshape our diet, our nights, our migrations, our social lives, and eventually our technology, then that ash is more than evidence of an ancient flame. It is evidence of a relationship that still continues inside your life. You eat food transformed by heat. You live in a civilization built around increasingly sophisticated forms of energy, and all of it reaches, however distantly, back toward an ancestor looking at a dying flame and deciding it could not be allowed to go out. Because perhaps the strangest thing about fire is not that humans discovered it. We didn't. Fire existed long before anything human walked the earth. The strange thing is that we learned to keep it, to feed it, to carry it, to teach others how to make it, and then, slowly, to build almost everything else on top of it. So if humans had never mastered fire, history wouldn't simply have been colder. It might have belonged to a completely different kind of creature. And the person watching this video might never have existed at all.